Welcome back to the deep dive. If you've ever looked at environmental problems, maybe invasive species, and thought, why are we always cleaning up messes instead of stopping them? Well, this deep dive is definitely for you. We're digging into a really fascinating paper today. It's called Take a Risk, Preferring Prevention Over Control of Biological Invaders, and lead author is David Finnoff. And it tackles this really counterintuitive question. When you're trying to manage these big environmental threats, why does being cautious often seem to lead to, well, much bigger risks down the road? It feels wrong, doesn't it?
It really does. And this isn't just some abstract academic thing. This paper gets at something huge, impacting ecosystems, our health, our wallets, really. Invasive species, they're like biological pollution, right? They cause all sorts of disruption, environmental, medical, economic. Just think about things like the West Nile virus, or how leafy spurge messes up grazing lands out west, or even the North American gray squirrel in Europe. And then there's the zebra mussel, a classic example. Costs industries, especially power plants, billions just by clogging things up. What this research shows, and it's kind of startling, is that our very normal human desire to be careful, to want a sure thing, it can completely backfire. Managers trying to do the right thing, trying to be cautious, end up shying away from prevention because it feels uncertain. And that, ironically, lowers overall social welfare.
Wow. Okay, so being too careful is actually reckless.
In this context, yes.
Ugh.
That's the paradox.
All right, let's unpack that. So a manager facing an invasive species threat has like two main buckets to put their money in, right?
Exactly.
Yeah.
You've got prevention, trying to stop the invader from getting a foothold in the first place.
Like tighter inspections, ballast water rules, that kind of thing.
Yeah, reducing the likelihood it even establishes. And then you have control.
Which is dealing with it once it's already here.
Right. Trying to reduce the population, limit the damage of an invader that's already settled in.
Okay, simple enough. But you mention language differences.
Yeah. This is interesting. When ecologists talk about being precautionary, they usually mean prevention. Like, the safest, most cautious thing is to keep the invader out completely. Zero risk.
Makes sense.
But for economists, and this paper comes from that perspective, precaution is more about your attitude towards risk. It's about risk aversion. It's about how you make choices to maximize well-being, given the risks and the tools you have to fight them. It's a preference, not just an outcome.
And in the real world, what do we actually see managers doing?
Well, that's the puzzle. We often see them waiting. They wait until the invader is established, causing problems, and then they, as the paper puts it, scramble to limit the damages.
So more control, less prevention, even if prevention might be cheaper in the long run.
Exactly, which makes you ask why. Why neglect the seemingly smarter long-term strategy?
And the paper argues it's not because they're bad managers.
Not at all. The core idea, the really clever part, is that this neglect comes from this deep link between how we as humans feel about uncertainty, our risk preferences, and the actual technology we have for reducing that risk.
Okay, now I'm hooked. How does that connection work?
So risk here isn't just one thing. There's the obvious risk, right? The invader arrives and causes millions, maybe billions, in damage.
Yeah, the zebra mussels clogging pipes example.
Right. But there's another risk, a more subtle one managers worry about. It's the risk of spending money on prevention for nothing.
What do you mean for nothing?
Well, you spend all this money on, say, port monitoring, but maybe that specific species was never going to arrive anyway. Or maybe you would have arrived but died out on its own.
So you wasted resources fighting a ghost threat. The opportunity cost.
Precisely. You could have spent that money on something else, and that uncertainty, that wasted resource risk, is key. And here's the counterintuitive finding. The more cautious, the more risk-averse a manager is, the less they tend to invest in prevention compared to control.
Wait, so the cautious person avoids prevention. Why? I thought prevention was the cautious move.
Not in terms of certainty of the investment. Think about control first. Let's say you spray herbicide on an invasive plant.
Okay.
You spend X dollars, you spray, you see dead plants, boom. You get, quote, certain benefits now. It's tangible, measurable. You can point to it and say, my money did that. The technology's productivity is relatively less risky.
Right. You see the immediate result. Makes sense for justifying your budget, too, I bet.
Absolutely. Now think about prevention. Its productivity is way more uncertain.
Like the port monitoring example.
Exactly. You spend millions. Did you stop the nasty critter? Or did it just happen to not show up this year? Or maybe it showed up but couldn't survive the winter.
Yeah.
You just don't know for sure.
There's no dead body to point to.
Right. Prevention only reduces the chance of invasion. It doesn't eliminate it, and it certainly doesn't give you that immediate certain payoff that control does.
Okay, I think I see the dilemma now.
Yeah. So if you're a risk-averse manager, you value that dollar spent on control, with its definite visible outcome, much more than the same dollar spent on prevention, where the benefit is uncertain, maybe far in the future, maybe never even needed.
So you avoid the uncertainty, even if it means reacting later.
You avoid the uncertainty of the investment itself. You favor the sure bet of control over the gamble of prevention.
That's like, choosing to definitely patch a small hole in your roof right now, which you know needs doing, versus investing in a super fancy, maybe it works, maybe it doesn't hurricane shield for the whole house.
That's a great analogy. The risk-averse person patches the hole every time, even if the hurricane shield could save them from total disaster later. They prefer the certain small win today.
Even if it leads to a bigger loss tomorrow.
Exactly. And to test this idea rigorously, the researchers didn't just theorize. They built a model, an integrated bioeconomic model.
Bioeconomic, meaning it combines the biology of the invader with the economics of managing it.
Precisely. And they solved it using something called stochastic dynamic programming, or SDP.
Okay, SDP sounds complicated. Break that down for us.
Think of it as a way to find the best strategy over time when things are uncertain. It's like playing chess against thousands of possible futures simultaneously. It runs simulations. Maybe the invader arrives early, maybe late, maybe it grows fast, maybe slow, maybe control is cheap this year, expensive next year, all these possibilities. And the SDP finds the spending plan, how much on prevention, how much on control each year that gives the best expected outcome, the highest social welfare across all those possible futures, considering the manager's attitude towards risk.
Got it. So it figures out the optimal moves under uncertainty. And they use zebra mussels for this. Why them specifically?
Zebra mussels are kind of the perfect case study. They spread fast, the damage they cause, clogging pipes in power plants, water treatment facilities is immediate, easy to measure, and super expensive. Billions since they showed up in the late 80s.
So the costs are really clear.
Very clear. The model looked at a hypothetical lake, maybe somewhere in the Midwest, where you have industries like power plants directly affected.
Yeah.
And there were two main players in the model's world. First, the manager making the big decisions on prevention versus control spending for the whole lake.
The collective good decision maker.
Right. And second, there was myopic firm. Think of it as the power plant. Myopic meaning it just reacts to the current situation.
It doesn't plan long-term for invasion.
Nope, it just deals with the muscles it has right now. If the pipes are clogged, it has to adapt, maybe run its cooling systems longer, burn more fuel, whatever it takes to maintain output. And that adaptation costs money.
Okay, so the manager tries to minimize invasion, and the firm just pays the price if the manager fails.
Essentially, yes. And the manager's decisions directly impact the firm's costs and ultimately the overall welfare.
And to see how caution played out, they modeled different manager types?
They did. They tested 4 levels of risk aversion. You had risk neutral, or RN. This manager just cares about the average outcome. A dollar is a dollar, certain or uncertain.
Okay, purely rational based on averages.
Then weakly risk averse, RA1, moderately risk averse, RA2, and highly risk averse.
RA3.
And RA3 is the super cautious one.
That's the one who really, really hates uncertainty. They'll give up a lot of potential gain just to avoid the possibility of a bad outcome or a wasted investment.
So what happened when they ran the simulations with these different managers?
The results were stark, really clear. As risk aversion went up from RN towards RA3, the optimal strategy consistently involved spending less on prevention.
Less prevention.
And more on control. Every single time, across the simulations.
Wow. And did they put numbers on that? How big was the effect? Get this. Using a pretty standard discount rate, like 3%, moving from the risk-neutral manager to the highly risk-averse, RA3 manager, led to a 115% increase in the average annual probability of the lake actually getting invaded by zebra mussels.
Whoa, hold on. 115% increase in invasion risk, just because the manager was trying to be more cautious.
Exactly. Their aversion to the uncertainty of prevention spending directly led to a much higher chance of the very thing they fear, the invasion itself.
That's kind of mind-blowing. It's the complete opposite of what you'd expect caution to do.
It is. And that higher invasion probability sets off a chain reaction. More invasions mean, obviously, bigger mussel populations over time.
Which means the power plant.
The power plant has to spend more on adapting. Higher operating costs, more fuel burned, maybe service interruptions.
So the whole system suffers.
Right. The bottom line was crystal clear. The strategies chosen by the more risk-averse managers resulted in significantly lower overall social welfare compared to the risk-neutral strategy. Everyone was worse off because the manager played it safe.
Did they check if this result was just some weird artifact of the specific numbers they plugged in for zebra mussels?
They did extensive robustness checks. They changed the costs, how effective prevention and control were assumed to be, even the maximum number of mussels the lake could support the carrying capacity.
Mad.
The core finding held up. Under risk aversion, prevention spending was always lower and control spending always higher compared to the risk-neutral baseline. The pattern was incredibly consistent.
So it seems like a fundamental consequence of risk aversion itself in this kind of problem.
That's what they argue. They call it the direct effect of risk aversion dominating. Faced with a choice between a sure thing, control benefits now, and an unsure thing, prevention benefits maybe later, the risk-averse manager just instinctively prefers the sure thing.
And since you have a limited budget,
Right. Prevention and control are substitutes here. If you pull money from prevention because it feels too uncertain, that money tends to flow into control almost automatically.
which leads to that policy paradox you mentioned earlier.
Exactly. The approach economists label risk neutral, just playing the averages, actually turns out to be the most precautionary in the ecological sense. It leads to less invasion, less damage.
And the highest social welfare.
Correct. The best outcome for society happened when the simulated manager was willing to, well, take a risk on prevention, accepting its uncertainty.
Were there other interesting patterns? Like, when did the cautious managers cut prevention?
Yeah, that was interesting too. The model showed risk-averse managers tended to stop funding prevention much earlier, particularly at the beginning of the planning period when maybe the threat seems distant, and also near the end, maybe when budgets are tight or winding down.
But aren't those critical times? Like, the beginning is when you most want to stop it getting established.
Absolutely. And near the end, you don't want to let your guard down before a transition. So by cutting prevention during these crucial windows, they made the system even more vulnerable, compounding the risk.
Now, you mentioned this model used SDP, stochastic dynamic programming. Does that have limitations?
It does. A key assumption in SDP is basically perfect foresight about the probabilities. The model knows the range of possible futures and their likelihoods.
Which real managers don't have.
Exactly. In the real world, managers are dealing with much deeper uncertainty, often without good probability estimates. So if anything, the paper suggests that real-world risk-averse managers might make decisions even further from the optimal than the model predicts. The 115% increase might actually be conservative.
That's a sobering thought, and this was focused on zebra mussels. How generalizable is this? Could it apply to, say, invasive plants or insects?
The paper suggests it's likely applicable to many aquatic invaders where the dynamics of establishment and damage are similar. But they are careful to note that testing it for, say, terrestrial species or invaders with really different biological characteristics, that's definitely an area for future research. The core mechanism might apply, but you'd need to check.
Okay. Is there any good news in all this? Does the paper offer any way forward?
There's actually a really important point about technology. One reason prevention feels so uncertain is that, historically, predicting which species will arrive where and when has been incredibly difficult, like finding a needle in a haystack.
Right. The uncertainty problem again.
But invasion forecasting science, using things like trade data, species distribution models, genetic tracking, it's gotten dramatically better in recent years. We're getting much better at predicting risks.
So if we can predict better, then the uncertainty around prevention starts to shrink. If you have a much better idea that species X is likely to arrive at port Y next year via shipping route Z, then investing in prevention targeted at that pathway feels a lot less like a gamble.
It becomes a more calculated risk, maybe even closer to a sure thing.
Exactly. So the paper implicitly suggests that incorporating these advanced forecasting tools into management planning could be crucial. It can actually nudge even risk-averse managers towards more prevention simply by reducing that perceived uncertainty. Okay, so wrapping this up, what's the big message for anyone listening who cares about environmental policy or just how we manage these huge, costly problems?
I think the core message is that our intuition about caution can be dangerously misleading in this specific context. Trying to be safe by avoiding uncertain prevention actually makes us less safe.
It leads to more invasions, more damage, higher costs, lower social welfare.
Right. So to really protect our ecosystems and our infrastructure effectively, management approaches and the policies that guide them need to embrace prevention, even with its inherent uncertainties. We have to be willing to invest in stopping problems before they start, even if we can't guarantee success every single time.
It means accepting some level of risk in the investment itself to achieve much lower risk overall.
That's the key. And maybe a final thought to leave people with. Given that invasion forecasting is getting so much better, reducing that uncertainty barrier we talked about, the real question becomes institutional, doesn't it? How fast can our agencies, our policies, our funding structures actually pivot? Can they shift away from the reactive, control-focused mindset that feels comfortable and certain towards a proactive, prevention-focused approach that modeling like this shows is ultimately far better for society? Making that shift happen is the next big challenge.
A really crucial challenge. Fascinating stuff. Thanks for walking us through it. And thank you for joining us for this deep dive, exploring how sometimes taking a calculated risk is the most cautious thing you can do.